Good morning, mathematicians. We are looking at week 24. We're starting us off with this Monday column. Let's go ahead and begin with modeling our decimal. I'm going to model 7 tenths vertically. That means I'm going to shade 7 out of 10 rows, actually columns, because I'm doing this vertically. So I am thinking about 10 complete columns being in the hole. Notice I have shaded 7 of the 10, right? So vertically, up and down, I see 7 out of 10 shaded. Now, boys and girls, I'm going to model my second factor, which is 8 tenths. I'm going to model that by shading 8 out of 10 rows. When I shade these 8 out of 10 rows, and now compare that to what I'm seeing with the 7 out of 10 columns, I can clearly see where the answer lies. The answer lies in this section because I have overlap. When I model multiplying fractions, this area right here that now has yellow and orange overlap, that's where the answer is. I could count those individual hundredths, but I don't need to do that because I know this is really an array that is an 8 by 7 array. 8 times 7 is 56. So I know 7 tenths times 8 tenths equals 56. And they're 56 what? Well, they're 56 individual squares, and those individual squares represent the hundredth place. So my answer is 56 hundredths. Boys and girls, when we look at this question, I see a couple answers that my students are coming up with. I'm going to show you 2 different ways that students have thought about this. This is asking us not to subtract this for exactness at first. At first, I'm just going to say an approximate value. So some of my students have said, well, 8 and 47 hundredths rounds to 8. When compared to if it's closer to 8 holes or 9 holes, it rounds to 8. 4 and 52 hundredths rounds to 5 because it's closer to 5 than 4. So those students that rounded it to the nearest whole, they found their answer to be 3. That is one great way to think about it. I would just need to explain that I rounded it to the nearest whole. Then I had some students, excuse me, who actually thought instead about subtracting their whole number values first, 8 holes, right? We're looking at the whole number, minus 4 holes equals 4. And then those students said, well, 47 minus 52, both of those hundredths, 47 hundredths minus 52 hundredths, that's very close to being 5 tenths minus 5 tenths. So that would equal 0. So those students said, well, our answer would be close to 4 because when I subtract those decimals, they're very close to each other. So I'm just going to let those cancel each other out, and those are going to equal 0. Now, again, if you explain your answer with this, I subtracted my wholes and got 4, then I knew my decimals were close, so I let those cancel each other out, and I had my answer to be 4. That's one way you could explain it. Another way you could explain it would be to say that you rounded the entire decimal value to the nearest whole, and you got an answer of 3. I'm going to know which way you did because you're going to explain it here, okay? I should see a sentence that tells what your problem solving was, what your thought was that got you to an answer of 3 or got you to an answer of 4. Okay? Now, down below, we're all going to have the same answer because here we're going to solve this for exactness. No longer an estimation. Now we're going to solve this to get our exact answer. Boys and girls, 7 minus 2 is 5. 4 lose 5, I can't do. So I'm going to borrow from 8. I'm going to make that a 7. I'm going to give a group of 10 to the 4, so that becomes 14. 14 minus 5 is 9, and 7 minus 4 is 3. So our answer is 3 and 95 hundredths. Sure enough, I can see both of those answers were reasonable. This way actually got a little closer, but both ways I would accept as long as, again, like a great mathematician, you can explain your thought for your answer. Now, boys and girls, this question is a good one. We are asked to order our decimals. What I like to do when I order my decimals is I first write them in a line so that I can see my place values all lined up, and that way I know I'm comparing the tens place. I'm comparing the ones place, the tenth, the hundredth, the thousandths. Then I like to come and I like to plug in zeros where I don't have a place value in that number. When I look at this question stem, I see I'm supposed to put the least number as the first in my list. Oh man, there's definitely one number that's smaller than all the others. This number is the smallest because when I look at the tens, it has no tens. These numbers have 20, 20, 40, 20. This one has no tens. So my smallest number, the least value for sure, is this. This is going to be first in my list. Now notice I have three numbers. This one, this one, this one. That all have a 20 in the tens place, right? It has a 2, so it has a value of 20 in the tens place. Now these looks a little confusing. I was circling here so that I have a spot to label which one's going to be my second, my third, my fourth. That's why I have those circles. I'm determining that by looking at these place values. Well, so far, they're the same. They all have 26 for their whole number part. So let's keep going. We're moving down our place values. All of these also have a 1 in the tenths. I still don't know which one's largest. I look at my hundredths. They all have a 6 in the hundredths. So I have to go all the way over here to determine which one is the next smallest number. This one has 0 thousandths. So that's going to go second in my list. This one has 2 thousandths. So that's going to go third in my list. And this one has 4 thousandths. So that's going to go third in my list. That leaves us with one value, which indeed is going to be the largest value. Surely it is. It has 46. So even just the whole number part tells me that that one for sure is going to be the third. Boys and girls, what I am doing now is I'm simply writing these down to record them in that order that they need to be in. Take a look. I have now listed them as I decided their order would be. I love this question because what we're doing is we're remembering that fractions are teeny tiny division problems. Notice our example. We have 14 divided by 3 equals 14 divided by 3. We're going to continue that. 13 divided by 7 equals 13 divided by 7. 22 divided by 5 equals 22 divided by 5. And 39 divided by 4 equals 39 divided by 4. That's all you have to do in those problems. We're creating an equation that is also expressed as our fractions. Let's finish out this column with thinking about a fraction, putting it in words in expanded form. When I read this, I'm saying the word form and I'm hearing the fraction. This is 0 and 842 thousandths. So 842 over 1,000 will be the fraction form. The words will be what I just said, 0 and, when I bump into the decimal. Now read my whole number part, or my decimal part rather, as if it's a regular old whole number, 842. Here we go, 42. And then I name and claim the place value that it is sitting in. Well, it is sitting in thousandths. Lastly, boys and girls, we're going to do expanded form. This 8 has a value of 8 tenths. This 4 has a value of 4 hundredths. This 2 has a value of 2 thousandths. Boys and girls, we could put this in expanded form as well. If we put it in expanded form, I'm going to say 8 times 1 over 10 plus 4 times 1 over 100 plus 2 times 1 over 1,000. Boys and girls, that finishes out our Monday